Ladies and gentlemen, hello and welcome back once again to the briefing room. My name is Eric Cavanaugh. I will be your moderator for today's event. And folks, this is a really interesting show we have lined up for you today. Of course, we're talking about analytics, but the topic for today is really getting that strategic view. So the title is The Comprehensive Approach, a Unified Information Architecture. So we're really excited to have a newbie here as the analyst. Very excited to have that on board. We're going to have Richard Hackathorn with us today. And
hello.
Folks, hey, Richard, how are you? So let me go ahead and start moving through the slides here. So there's a slide about yours truly, and enough about me. The mission of the briefing room, as many of you know now, is to provide this really brass tacks view of what's going on here in the field of information technology and of information management specifically. We're trying to get down to understand exactly what these technologies do, how they work, why they work the way they do, and so on and so forth. So what we do is we have vendors sign up for the show, and then we come up with an analyst that we think knows the space pretty well but may not have recently briefed with that particular vendor, and they do not coordinate before the show. And that's really one of the key ingredients here, is that we want people to have a clear view of what's going on, and so we're trying to essentially reveal that organic conversation that occurs between an analyst and a vendor when a vendor is giving a briefing. So that's what we're doing here. We have a different topic every month. You can see that May is analytics. You can see, of course, that June is intelligence, and the other topics there are coming up. And we do that because we want you to have a apples-to-apples comparison as best as we can provide of vendors within a particular domain. So obviously, if you're looking to purchase enterprise software, this stuff is not inexpensive. It tends to be rather pricey. And let's face it, if you make the wrong choice, there could be some serious ramifications. So we're trying to empower you as the end user with as granular and detailed a picture of these technologies as we can get you. And that's why we have this tension between the analyst and the vendor. We don't want any kind of confrontation, but we do want really good probing questions, and that's why we designed the show the way we did. So analytics, of course, is a pretty broadly used term. And one of the things I find interesting about the current state of this industry is that you have this whole world of business intelligence that we all understand pretty well, very structured data, the data warehouse, for example, OLAP cubes that are built on top of that, traditional reporting and ad hoc queries, that kind of thing. But this whole other world of what's called big data analytics largely seems to be growing up somewhat on the side, or not exactly unified with the traditional world of business intelligence. So how can you get a strategic view of all these analytics? How can you bring them all together beyond just creating a dashboard, for example, to really understand what's going on in your organization and what's going on in the marketplace? And that's the topic for today, or at least that's part of what we're going to talk about today, is having sort of a unified architecture. We'll talk a lot about big data, of course, but I think there are going to be some questions about how you pull all this stuff together. So I think that's a pretty interesting topic because, let's face it, the whole purpose of all these tools is to allow you to glean insights from your data. And yes, there's a lot of marketing language in the industry these days, in the marketplace of ideas. Some of that language is a bit strong, but the whole purpose of the show here is to really peel away that veneer so we can get down to understanding exactly what these tools work, how they were designed, why they were designed that way, and what that means for you. So folks, I'm very excited to have one of the most well-known veteran analysts in the space with us today, Dr. Richard Hackathorn. I'm sure many of you recognize that name. He is widely published. He is a very wonderful presenter. He's all over the place. You can find information about him online, of course. Just look him up on LinkedIn or just Google him and you'll hear a lot of good stuff about him. So we're very pleased to have him today. We're also pleased to have Teradata. Let's face it, folks, Teradata is a powerhouse in the field of data warehousing. They've been very active for 30 years now. They've just been a force to be reckoned with. Very pleased to have them in the briefing room today. And of course, there was a landmark acquisition they made a while back of Aster Data. So we're going to hear how Aster Data kind of fits into that whole Teradata package today. So Chris Twogood, he's a VP of Product and Services Marketing over at Teradata. He's a very knowledgeable guy, so we're very pleased to have him in the briefing room today. And with that, I'm going to push his first slide, and I'm going to hand the keys over to Chris. And just a reminder, folks, send your questions into the Q&A or text them to us through the chat, or go ahead and tweet them with a hashtag of BriefR. And with that, Chris Twogood, I'll hand it over to you.
All right, thanks, Eric. Good afternoon, Richard. How are you today?
Good.
What I'm going to talk about is really a unified big data architecture. And we all hear about these concepts of big data. But what's happened is we've really established this evolution of ERP or transaction data, which really generated megabytes of real structured data. And then CRM came along and it generated more gigabytes of data because you're starting to do segmentation. And then the web came along and started to drive companies into terabytes of information because you're driving more dynamic pricing and behavioral targeting on the web. But then this move that has really driven us into petabytes is really what we characterize as big data. I mean, it's user-generated content, it's sensor information, it's social network type of data. And what's happened over time is the data variety has continued to evolve. It's not just about structured information, and the complexity of the types of data has evolved significantly. And what this does is it requires us to really rethink about how we analyze information. So if you look across the top here, this is the way typically IT organizations would work. The business users would determine what are the questions that I need to ask. And then IT would go off and they would build, classic BI. They would define the structure. They would set it out to be a repeatable type of analytic, and they would only capture into the warehouse the information that is needed to answer the business user's questions. But what has happened is we've really this big data has turned it on its head, where IT needs to be able to deliver a set of capabilities where you can capture all of the information. And then you use the data to tell the story and run big data analytics on this very multi-structured information and be able to do it in an iterative format so you can discover more information as you drill through in an ad hoc fashion. And then the business users really explore data for questions worth answering, not just predefining it up front. And so there are different technologies that address this in different ways. SQL is still absolutely the best way to do the top part of this chart. It's about performance and about structure. But a new technology around MapReduce really produces and provides a lot more flexibility in terms of being able to do single passes across a broad set of information to really discover patterns within the data. And so what this type of structure really drives us to need is a unified big data architecture. Because as IT and business thinks about their requirements, what they want to be able to do is they want to be able to capture information regardless of the data type. So it could be audio, video, it could be images, text information, machine logs from sensor data, CRM, supply chain information, ERP. They want to be able to capture that in a raw form and then be able to refine it by doing transformations, but then be able to discover against that data, to be able to uncover the nuggets of information and explore new patterns of data, and then be able to share all of that information with the enterprise and be able to execute it out so that everybody is being able to derive value. And business users want to be able to do it across a broad range of different technologies. Typically, business users use the language of business, which is SQL. But you also have different organizations within IT where they want to use Java or C++ or Python or R to do deeper types of analytics. So as this unified big data architecture evolves, you start to see the place where different technologies fit. So Hadoop is a very strong platform for being able to capture long-term raw data storage. And then from there, you can feed information into a discovery platform like Teradata Aster or into an active data warehouse where you're sharing a lot of information to a broad set of users within the enterprise. This doesn't mean that you don't capture this information directly into a Teradata Aster or a Teradata environment. For a lot of reasons, if you have a lot of reference data inside your active data warehouse, such as customer, store, inventory, you want to do your binding of that information directly within that platform. But it helps you look at a strong unified architecture where you can share information and result sets to be able to do the best types of analytics for the specific function required. And one of the things that we have as a goal at Teradata is really to be able to provide insights out of Hadoop to your business analysts. And typically what happens is Hadoop traditionally is really a foundation for engineers, people that code in Java or code in C++. They have to code almost everything. You have to scheduler, they've got to code. You've got to code security information. Now there are tools out there like MapReduce as a framework, Pig and Hive as a SQL emulator that helps, but it really is a very manual process, and IT really is the optimizer and makes sure that the data that's coming in from the engineers is really being optimized within the Hadoop infrastructure. And so with Teradata Aster and with Teradata, we've got a set of analytic portfolios which enable you to access information and do this type of data discovery. So in the Teradata Aster platform, we have the patented SQL-MapReduce that enables you to use the power of MapReduce, but enable it to have access from a business analyst or a data scientist or a quant. And so one of the key value adds that Teradata brings to the table is this ability to do analytics on Hadoop data through not only the SQL MapReduce platform, but also with all of these detailed, 50+ prepackaged analytics so that it's easy for a business user to say, I want to do a path analysis, or I want to be able to do a pattern analysis or a graph analysis within that data. And the business user themselves don't have to worry about, well, is that data sitting inside of Aster or is it sitting, inside of the HDFS foundation? So one of the things that we've created in partnership with companies that we work with on the Hadoop side is really looking at, what is technically different in the different types of big data analytics. And you start to look at data, and we break data into different schemas. So data that has a stable schema is really more of your, transactional type of data. Data that has a very strong audit trail, data that you would use to maybe balance your books at the end of the quarter. And this is your traditional transaction information, ERP data, inventory data, supply chain, and so on. But there's another set of data that really has an evolving schema. And typically this is data such as clickstream analysis, that has long strings of information, but the strings of information change dynamically because your website is evolving a lot more dynamically than we would see within our transaction set. It's not just web logs. It could be CDRs. It could be, IPDRs. It could be sensor logs, social profiles, and so on. But then there's another set of data which has no, has some format, but it has no real schema. And this is typically really represented as more unstructured type of data. And this is data that's captured by machines and typically represented as, images that are stored in this raw format, where you want to be able to do some focus on it, but be able to extract the metadata out so you can bring it into some specific type of structure. And then what we've done here is we've kind of showed against each of these data types, stable, evolving, and format but no schema, which is the right platform to do this type of function on. Across the top, we have the different functions themselves. So low-cost storage and retention, really no processing going on. You're really just dumping information in as a data hub. Loading and refining, we're doing things like pre-processing the information and really preparing it for downstream processing or cleansing the information. and then doing transformations where we might change from one structured data into another for being able to execute the analytics. And then reporting is really understanding what happened, where did it happen, and how often does it happen. And then the analytics are really driven more around user interactive ad hoc type of analytics. And so you can see here from a stable schema perspective, really transaction data, right? Teradata Hadoop are great foundations for storing information that is a stable schema, low cost storage and retention. And then Teradata is really the best platform across the rest of the process for being able to execute transformations and analyze information, because you're not doing a lot of data movement back and forth to a broad set of different platforms. On the evolving schema side, Hadoop for low-cost storage, Aster and Hadoop for a lot of the pre-processing, especially if you're doing key structures and joining with structured data and combining both SQL and MapReduce type of analytics. It's much more efficient to do that inside of a Aster platform. And then where you've got format and no schema is a fantastic place to execute Hadoop, to be able to do all the different transformations, to be able to do all the pre-processing and really pull metadata out of those detailed images so they can be used for analytics, leveraging MapReduce on the Aster front. So as I talked about this idea of a stable schema and a low-cost storage and retention foundation, Teradata has lots of different platforms that can meet specific needs based upon different workloads for stable schema. So you can see here in the first one, we have our Extreme Data Appliance, which has very large 2 terabyte drives, a very strong platform for low-cost storage and retention. It can do data prep and transform, but at a lighter level because it doesn't have as much CPU, but it does drive compression, and you have a list price here per terabyte of 4K. The Data Warehouse Appliance provides very strong platform for CPU-intense transformations, provides automatic compression, and can be used for more medium volume storage, and is around 11K list price per terabyte. And then a lot of people don't think about it this way, but your active EDW can be a good place to do long-term storage and transformation, especially if you're not having to move data around and the data is already sitting in your data warehouse. You have low latency, you minimize the data movement and the complexity, and you've got all your reference data right there inside of the platform. And we have some new technology in Teradata 14, which enables us to really compress data as it's on cold. So we identify as cold, and we can get it compressed and bring that low cost per terabyte. So if you really look at a unified, big data architecture and the data flow, it really does enable this data-driven business. So you can take your transactional data sources, move it straight into Teradata. You can use this unified analytic access through SQL and SQL-MapReduce to access data both in Hadoop and in Teradata Aster. And then as you have the specific analytic results, you can move that data out of the platform itself directly into the Teradata portfolio for being able to extend and use for SQL analytics. And then you can have your business applications directly on top of that Teradata foundation. But you can also have all of your different data mining and your analytical tools and users either accessing the Teradata layer or accessing the unified foundation for getting into Hadoop and Teradata Aster. So it really creates this strong foundation for being able to derive, get value out of big data, and then share it with the rest of the enterprise. So why don't I go ahead and turn it back over to Eric, and let's have an open dialogue about how you see this evolving in this marketplace, Richard.
Okay, and let me go ahead and give the keys of the WebEx to Richard. Hold on. Okay, it should be moving over to you right now. Okay, good.
Oh boy, I got the keys.
There you go. Be careful now.
Well, thank you, Eric, and thank all of you for coming today. I think we've got a great discussion here on the issues of unifying the data warehouses from the perspective of big data. I'd like to reiterate what Eric said earlier. This is an open discussion, so both Eric and I are looking at the Twitter feed for #briefr. So please drop your Twitter in there, or if you're on WebEx, drop a question in the chat channel, and between the two of us, we'll try to pick that up and get Chris involved with the things that he's talking about. So this has been a great opportunity for me in looking at how do you unify the enterprise data warehouse architecture given the things that we're starting to learn about now with big data. So I had the opportunity here to sort of sit back and say, okay, now from the directions that Teradata is going, what is our thinking? How should we think beyond the traditional or classical enterprise data warehouse? Well, the first thing is something that I agree with Chris. It's a new ball game here. Big data is forcing us to rethink the goals and architectures for data warehousing. And I was involved in the very early days of this, and saw some of the early attempts to put together collections of data that could really drive our corporations in better decision making. And I wrote and participated in a lot of the architectures for that EDW. But I've got to admit that big data is throwing us some curveballs here in this new ball game. That in the traditional sense, EDW was an exclusive collection of information, and we've got to move beyond that. We've got to think broader. That a lot of the goals that we had, especially in the early days, was a single version of the truth. We wanted to capture who we were as a corporation and make it drive our decisions at both the strategic down to the tactical levels. Structured data. I mean, unless you could structure the data, it wasn't important. We didn't have the technology to deal with it, but the point was that our applications either could not generate or consume other than structured data. Well, new ball game. And we could predefine things. We knew what we were looking for, and we simply had the right to report to spit those things out. Well, guess what? We're in a new set of issues here. And I'd like to bring out three of them and sort of pop up a level. I think Chris did a good job talking about some of the architectural components, some of the products that Teradata has that would fit into a unified architecture. What I'd like to do is contrast that and say, okay, now what's the principles? Where are we trying to go with this? And I think the first one here is that we have to shift from being exclusive to inclusive. That is a much more open type of architecture. The data cannot all be managed within the boundaries of our EDW. It's too much, too fast, et cetera, et cetera. We need to be more agile, more flexible, more responsive. Now, I know that some of you, and I've lived through it also, are thinking, well, how do you control an environment like that? Well, it's good. There's some challenges there on how to control that. I think some of the keys to understanding this open, inclusive type of environment is how do you curate, how do you acquire and understand and utilize new sources of data? There is a tremendous amount of data that is being collected and making publicly available, not just by government agencies, but many other information sources out there, and trying to tap into that for the corporation, I think, is going to be a huge competitive advantage for corporations in the future. And then how do you do exploration on that data in the future? So that's number one. Number two is the ever-changing multiple truths. I happen to think of a quote from Shakespeare where Hamlet is talking to Horatio and says, more things in heaven and earth are dreamt about your philosophy, okay? Well, Horatio doesn't believe in ghosts. Well, Hamlet just saw his father's ghost. So how do you communicate to someone who is sort of back in the traditional EDW world to say, hey, big data is a ghost here. We don't know what we do not know. We're exploring some new areas here. And for example, one of the things is in marketing optimization is trying to look at customers with multiple personalities. The way I interact, for instance, with Amazon in terms of purchasing books and many other things, you know, if you did the normal analytics on my behavior, you'd have to confer that this is several different people. Well, it's the same person, but I have different personalities, different needs. How do we enlarge the data warehouse and not treat me as just an individual, but really an individual who has a whole spectrum of different desires and personalities? And I think the whole area of semantic analysis is very critical here. Number 3 is discovering structure. I think a lot of the value from the data in the future is not just collecting it, but trying to do something with it, trying to mature it, trying to enhance it at every stage of the business process. And so how do we do that differently, and how do we build the analytics and data mining into our unified architectures so that they add to the data continuously? Anyway, that's sort of a high-level sort of reaction to the slides that Chris had. Now, as I looked at the different things that Chris was mentioning, his first slide was intriguing. It was one that talked about all the different areas of big data, and I'd like to bring Chris back in here, and let's talk about some of the emerging applications that are not just social networking. Seems like social networking gets a lot of play nowadays, but what are you seeing, Chris, as some of the killer applications in the other areas? And you often hear the phrase Internet of Things. Got any reactions to that?
I think it's a great question, Richard. I think there's a lot of things that as you start looking at the different data types, I think there's a couple of real misperceptions. I think number one is, oh, it's just about capturing the big data and doing the analytics on the big data. The reality is you need to be able to do analytics and combination of information that includes not only the emerging schema and stable schema information, but you also need to be able to combine both SQL and MapReduce functions to be able to look at patterns within the information. So it really has a lot more to do with the analytic than it really does with actually capturing of the big data. But we're seeing lots of very interesting use cases out there in the marketplace. You know, one of our customers at Mundo is actually capturing information about social networking within millions of different students and teachers, and really understanding influencers as to which teachers are more effective in communicating a certain subject or delivering better learning. We're also seeing a lot of evolution. It's not about, CDRs are still important, but it's really about the IPDR, the Internet Protocol Data Record that is generated by smartphones. And typically we see 100x more data volume in terms of how different users are using the smartphone information for accessing and looking for patterns.
Can you drill down a little bit more in that? What kind of patterns would emerge from going a little deeper into the call records?
Well, it's interesting because a lot of people talk about you have to go all the way down to, you know, in investigating into the packet. And I don't think you have to go that far. It's really more about the types of information that's being captured now that we have smartphones and what we do not only from, you know, making calls on our phones, but also in terms of the applications that we use, in terms of when we access the internet and when we access mobile applications. In fact, one of the applications is really looking at application logs inside of mobile apps, right? Where are people going? What are they doing within this? And how do we influence play within that? In fact, one very interesting usage has been within gaming technology, where we start to look at ensuring the relationship between the player and the game itself to make sure that they have the tools they need to advance through the game, to be able to analyze things like the number of shots hit versus the number of shots taken, and actually give them different tools to improve their gameplay. So I think there's lots of interesting extensions from web information to smartphones, application logs, and gaming.
Do you see much in manufacturing? I mean, I'm trying to hit this non-social area. Anything in terms of more efficient supply chains? Are we tapping in the big data in that area? Have you bumped into customers?
You know, a lot of the areas in manufacturing have to do more with sensor data. I mean, sensors are being placed more often. I mean, we see them on, you know, every few feet within an oil pipeline. And we see it on all the different assets within the manufacturing flow with RFID chips. And so the information that gets collected and processed really provides a, you know, net new insight in terms of how manufacturers are understanding their raw products, their raw goods, and how they really transform that information. Another interesting industry is really healthcare. One of our customers, Aurora Healthcare, what they do is they really look at detecting patterns of information to determine better disease outcome. So using big analytic type techniques like path analysis to create what we call an interaction map. So they can look at, okay, what are the series of tests, what are the kind of treatments, what are the facilities, what are the doctors, and how do we combine all of this information to not only lower the overall, you know, cost of care, but to improve, you know, specific outcomes. And they've really been able to improve conditions and then improve costs overall by being able to use big data types of analytics.
Maybe I'll throw this out to our attendees here. Anybody out there see a really big data application that's not your typical social networking? You know, healthcare or the manufacturing. Just throw it up on the Twitter, and we'll tell people about that. Well, let's move on a little bit here.
Let me just add one more, if I could, Richard. I think the other thing that's really interesting that we're starting to see a lot of play on is within more financial institutions, and it's really combining more of the big data with your more stable schema data for being able to do things like understanding a path analysis for when accounts are closing. So, you know, maybe they have a pattern where it says, I called into the call center, you know, maybe then they made a comment on the Twitter feed, and then maybe they went into the branch. And by analyzing this pattern, we actually were able to understand that people that take those 3 steps in combination have a much higher likelihood that they're going to close their account than if they took other paths. And so what that does is it enables you to combine, you know, more traditional SQL types of analytics with MapReduce and be able to understand through big data analytics this pattern and then use it to more effectively target your customers with different types of campaigns or, you know, win-back offers, or even stop it before they actually transition outside of, you know, a customer bank to some other competitor.
Yeah, I think that analyzing event sequencing is definitely has a lot of potential to it. I remember 5 years ago that was extremely difficult, but often a manual process. But now we're seeing some really good analytics like the that you just mentioned, being able to help us there. Let's just, go down these questions a little bit more. The one thing that strikes me about big data is its velocity. That is, number of terabytes, per minute that get, drinking from the fire hose sort of thing. How do you see this unifying architecture handling that kind of velocity, and can you give some examples from some of the companies that you bump into?
That's a great question, because what happens, and that is always the part of the challenge within big data, is that we are generating literally terabytes and petabytes of information, but what we don't understand is what parts of that information really has value. How can we monetize that information to really bring value back to the business? Quite often I think that a lot of things around big data is really, companies worrying about what other companies are doing and trying to harvest key information out of this big data. And because it's coming in at such high volumes, it really is almost too big for typical tools and resources, especially manual resources, to make sense out of all of the information. So what you want to be able to do is ingest all that data really in its raw format and bring it into the data hub layer, so that you're able to really store and refine that information. And you can decide over time, right, is that information that I want to persist? Do I want to keep it there from a retention standpoint, or is that data that I just want to have pass through, and I'm going to dump some of it on the floor, but I'm going to pull out the nuggets and then move it into other components within the overall unified big data architecture. There was a great analogy done one time, and I don't know, Richard, if you've seen this Lithrow camera. But this camera, I think, is actually a nice analogy against what we're trying to do with big data, right? It captures all the light, right? And you capture everything that goes on within that image, and then you focus it later, right? And which is a very different kind of view, where we typically, with your 35mm cameras, you've got your focus, you zoom in on what you want and you capture it, and then that moment is lost. But now with this new kind of camera, you can change your focus within it, you can change what you're analyzing, and you can change the visualization of that information really dynamically because you've captured all the light. And I see that exact same thing with big data. You can bring in the information. You really need to be able to have analytics to run against that to uncover patterns of information and be able to store it in its rawest format so you can re-look at it with a different lens at different points in time. So I think the whole idea is capture the information, and then you can determine what focus do I want to take on the data, and you can also determine, do I want to continue to persist it, or do I want to just let it fall off and then bring more data into the unified big data architecture?
Well, the challenge here is balancing with the other point of view, is that if you don't know what you're looking for, then you're very inefficient at capturing all this. I'm sure that professional photographers look at that OmniFocus camera and say, well, if you knew what shot you wanted to take, you wouldn't need that technology, right? So it's kind of the other perspective. But I think that from your perspective, a lot of corporations are getting into marketplaces that are not the same old. They're changing quite dramatically and quite rapidly. So, in those situations, having technology where you're capturing more than what you need at the moment in hopes to go back to do the analysis, which kind of brings us up to this fourth question here on data expiration. I'm a data analyst from way back, and I have often cited that we should be doing much more exploratory things, and it just happened recently to become more popular now. And I'd sort of like to get your perspective, Chris, on how some of your customers are using some of the exploratory features that you're offering with Aster and Hadoop now for more exploratory things. What sort of discoveries, surprises do they come out of this? I'm curious.
Yeah, I think that's a really great way to look at this because, and as you pointed out, Richard, we really call this data exploration, data discovery. And we think it is a great way to really have the data itself inform the business about trends. When we, as I pointed out in the first chart, when we predefine the data to answer the business question, then you're losing some of the ideas that are going on within the data in terms of certain patterns. When you model all your data up front and then you bring it in and then you feed it into specific reports, you're not really able to do a lot of ad hoc type of discovery. In fact, what we think about is we really think about data discovery as almost the new data mining, because what it does is it enables your traditional business analysts or your mainstream business analysts to start to think about what are the root causes of this, or what types of information might this data tell me? What kind of information around different types of patterns and time series and path types of analysis can I uncover that I might not have been able to uncover before? Like one example, is just typical web analytics. SQL is really great at saying, well, how many people visited this specific web page? Or how many people went down a specific path from when they came into the website to maybe a transaction. But what SQL is terrible at is telling you, let me look at everything that everyone did in all their interactions and tell me which is the golden path that most people went down that drove to the most interactions and transactions. And big data analytics lets you do that kind of function. And with these discovery tools like Teradata Aster, you can quickly and dynamically change the inputs and the outputs. So you can say, well, let me look at patterns of all those that came into the home page, went to the transaction page between these different dates. And then you can just change that and compare it and contrast it. And this kind of iterative types of analysis is what drives business analysts. It's not just about, let me have predictions, see a result set, and go act. It's about asking a question, understanding the result set, asking more questions, and really discovering through this iterative types of process to really explore and come up with these unknown relationships that the data is telling you, but stuff that you're not just coming up with on your own.
Hey, I just happened to see a tweet here from Bloom Reach Inc. and gave me a link, and there's a video behind it. Obviously, in this discussion, don't have time to do it. Like to see if Bloom Reach would come back and give me a concise description of this big data applications, and that's not social networking, and I'll look for that. So let's move on here, Chris. I think another area, as you were talking, that intrigued me was this second question on here, and that is Hadoop and Teradata Aster. And I noticed that a lot of your architecture there, they were both being used by analytics of various types. And the question sort of came to me, well, do you need both of them in a unifying architecture? Can one substitute for the other, or what's the trade-offs between those there?
Well, I think if you look at what's really different between Teradata Aster and Hadoop, Hadoop is really a distributed file system, right? HDFS with kind of a native MapReduce function on top of that. And there are some tools out there like Hive that do some SQL emulation, but they're very inefficient in terms of it's kind of like SQL-like language, but it doesn't really drive strong joins, strong aggregations, where what Teradata Aster does is it really is a MPP analytic platform, which has native MapReduce, but it's delivered with embedded SQL MapReduce on top of database file structure. So that enables you to have all the enterprise richness of security, of scheduling, of being able to do interactive types of analysis, and being able to use standard ANSI SQL, and that means you can use any standard BI tool. So whether you're using Tableau or Business Objects or Cognos, your business users can now have the access to this powerful MapReduce kind of framework. And what Teradata Aster does is it really helps bridge the science of data to the art of business. What also we do is we create, and we have in the package 50 prepackaged analytic functions and applications, things like path analysis and pattern, and being able to understand graph analytics against different nodal relationships. And so these prepackaged analytics make it easy for business users to invoke questions against the detailed data. The other biggest difference between really Hadoop and Teradata Aster is Hadoop has heavy reliance on skilled developers. And you've got to be able to have engineers that understand Java, understand C++, understand very detailed functions, because they have to write nearly everything to be able to execute on this. It's not a strong interface for business users. And like I said, IT and the people around IT are really the optimizer, where with Teradata Aster, you've got data locality, you can do very fast joins, you can do very sophisticated optimizer-aware functions. In fact, we've done a recent benchmark where for even simple web analytics, Teradata Aster performed like 35 times faster than Hadoop, and that was just on the processing time, but there was also a significant time just getting ready to do the analytic itself. So I think you really want to look at how they complement each other. Hadoop is a good platform for being able to store long-term, raw data, but for being able to do iterative type of discovery analytics, it's not really designed that well because it does a lot of swapping within the infrastructure, and really you need to be able to do that in the Teradata Aster kind of framework.
Yeah, but I'm also seeing that a lot of the universities have focused on Hadoop and its components along with Java and the like, and are producing people who have those skills. So, and those are the people that are starting to do some of the cutting edge analytics. So I guess what that leaves me is that if you're a progressive corporation who has a lot of business users that don't have those skills, but are also hiring and enlarging your groups in advanced analytics with people that do have those skills, then you're gonna have to bridge the two technologies, and I don't think, at least from my perspective, I don't see very many vendors that are trying to do Hadoop and something that complements it.
Well, I think there's a couple of things to that. I mean, I think data scientists are really playing an important role in the market today, but the challenge is there's just not enough of them, right? And like as an example, a data scientist could create a MapReduce function, but then invoke that within Teradata Aster for the business community to be able to leverage it. The biggest thing you want to be able to do with data scientists is have them do that really thought-provoking type of process, not administering a technology infrastructure. And part of the challenge that we see with things like Hadoop today is that there's still a lot of things that you've got to be able to do just in maintaining it and having schedulers and making sure that the data is swapping appropriately and making sure that you have integrity and referential integrity inside of the data. And a lot of times your support costs in doing that are going to be much higher than it would be if you do it inside of Teradata or inside Teradata Aster. So I agree with you, Richard. I think data scientists play a very important role inside of the unified big data architecture, but we want to make sure they're focused on the right type of job function.
Yeah, a lot of exciting things coming out there. looked at some of the current research that's happening in this area. I think last year actually, and I was amazed at the number of good research articles were coming out every week, so there's a lot of new thinking, a lot of new techniques that will eventually migrate back into the the typical tools that we're seeing today. So there's a lot happening. I just noticed trying to stay on top of the Twitter feed here. We were discussing data discovery a few minutes ago and had a good discussion on that. I think that the point that now I just lost it. I'm trying to go down to these tweets here. Hold on.
We have a great tweet stream going today, by the way, folks. Feel free to send your questions there. You can also send it right through the Q&A in your webcast console, but a lot of good questions. We've got them queued up and ready to go. So go ahead, Richard.
Yeah, I think the point about data discovery is that it does depend on not just the skills that people have about it, but also curiosity. I've had a number of conversations with a colleague, Bill Franks, who's just came out with a new book on taming the big data wave. And I think he has appropriately put his fingers on the fact that curiosity, insatiable curiosity about what is the data saying to you, has more to do about effective data discovery than the tools themselves. And somehow we've got to teach that, cultivate that, and if you're trying to build a group in this area, somehow filter and hire based on those criteria. And I think it is exciting. It's an exciting new profession there.
I think that's a great point, because what we've done with traditional BI is we've delivered them reports, and I think a lot of business users come in, Monday morning, and they get their set of reports, and they go make their decisions and act on the business. But I think that there is, in addition to data scientists, and I'm not sure what we call it, if it's a business scientist, but there's a set of capabilities that we need to really be able to entice business users to have this curiosity and this idea about asking more and delivering more, and by having that catch up with the tools themselves, they'll be able to really uncover new patterns that they didn't know before that can completely transform the way that the business executes in the marketplace.
Mm-hmm. Yeah, another aspect about this, the data discovery, is the important role that visualization is now playing in that kind of analytics. In fact, the academics, I think, got it right a few years ago, and they coined a new area called visual analytics. It's the combination of the two, and how do you come up with algorithms that really complement one another in terms of displaying something, having the user interacting, and through the interaction drive the analytics further. And so you're starting to see, a new generation of products such as Tableau and Spotfire and ClickTech and so forth. But I think that's going to be a growing area that is really going to drive this whole area of data discovery. Let's. I wanted to come back to another question here, and that's the whole, shall we say, management of the data. As you're moving big data around, there is a lot to move in terms of volume and velocity. How can you be smart about managing the data without duplicating things in a number of multiple stores? You got any thoughts on that, Chris?
Yeah, Richard, I think it's a great question, right? And I think you need to look at data flow really in two different ways. The first is really access the data in the tier that it sits for the specific analytics. You do not want to move lots of data around just for the sake of moving data around. And that's why it's really important to say we want to have the data inside the Unified Big Data Architecture tier that best fits to that specific type of analytic or function. And that's really where that matrix came in, where I described all the different functions from storage and transformation all the way to reporting and access. So what you want to be able to do is you want to be able to have, from a business user perspective, that they come into a single tool. As an example, within what we do with Teradata Aster and SQL-MapReduce is you can access information through that analytic framework that's sitting in Hadoop and only bringing back the data you need into memory to be able to answer the analytic itself. And then you can decide, do I want to persist the result set or not? So what I'm not doing is I'm not moving massive amounts of data from Hadoop into Teradata Aster, and then I'm not moving massive amounts of data from Teradata Aster to Teradata. I'm only providing the information that's required. It could be the result set that I want to share with a larger enterprise, and it could be that I'm just accessing it through this unified layer. The other key thing to think about is you might not persist data at certain levels within the unified big data architecture depending on the value that you discover. If you discover that the data itself has huge amounts of value for ongoing analytics, then you want to persist it in the layer that makes sense. But a lot of the big data information that you bring in to the unified architecture, you might not end up keeping, but you can decide that. Do I store it in a very low cost per terabyte type of storage like Hadoop or Teradata with our Extreme Data Appliance, or do you bring it up into the higher tier that you're sharing with a broader set of users? So a lot of the goals within the unified big data architecture are actually to minimize data movement throughout the 3 different tiers.
I'm just happened to discover in WebEx here some of the chat and Q&A stuff here. I noticed that Al Rago mentioned intelligent water, electric, and gas meters as an area of big data in the future. Also, real-time risk management in finance as another example. And then Lynn Myers says, I've seen sensor data use cases for transportation of food and other perishables. This can also drive when prices need to be modified to move the product. So here's some examples from some of the audience today.
Yeah, I think it's really good. In fact, it brings a couple of things to mind. I mean, if you look at smart meters and being able to capture that information and being able to provide analytics to consumers so they can really decide for themselves how they want to be able to execute their specific usage patterns within their electric environment. We've also seen fraud quite a bit where you're wanting to use social network analysis to really identify what we call a bad actor inside of a network where money is flowing, where there might be issues around money laundering. So those are some great uses and additional expansion of big data analytics.
Mm-hmm. Hey, Eric, did you see some questions on the chat channel that I might have missed that you ought to pop up?
Sure, we have a whole bunch of them here, and Richard, feel free to chime in again. Let's go ahead and jump to some of these attendee questions. One that I thought was a really good and incisive one is about data virtualization. So, Chris, I'll throw it out to you. How big an impact will data virtualization have on bridging these worlds of BI and big data analytics, in your opinion?
Well, it's interesting. I mean, data virtualization really has come about to really help improve kind of the resource utilization of a number of different, infrastructures and how you access information. I still think as you look at a unified big data architecture, that virtualization is going to play some role, but it's not going to be a game changer in terms of this, because you're still going to have to move and ingest all the different data. You're still going to have to do the discovery types of analytics, throughout the information, and you're still going to have to share it. I think the challenge is to make sure that you leverage technology that gets very high resource virtualization and resource utilization, like Teradata. I mean, Teradata, we see almost 100% utilization because we virtualize all the different processes. So you're sharing data and processes among, that kind of framework. So, we'll continue to watch virtualization, but I think it's going to have a longer term impact, not a short-term impact.
That's an interesting point. Okay, good. We've got a whole bunch of great questions here. One of the attendees wants to know, I'll just read the question out loud here. It still seems that there is quite a big gap between the advanced data visualization that tools like MicroStrategy, and of course there are others that I'll throw in like Tableau and QlikView and some others, has created, and then what you're starting to get out of tools like Hive. Now honestly, Hive is still pretty new, but what do you think about that gap, and what do you think is an ETA for that gap being bridged?
Well, it's interesting. I think if you look at the value that tools like Tableau and QlikTech provide, is really this interactive type of very rich advanced visualization. And so they've got some really great visual tools that enable you to look at big data, whether it's clusters, whether it's patterns and path maps within the foundation. But the challenge with those tools is that they don't speak MapReduce, and that's really the role that Teradata Aster plays, is we provide this SQL to MapReduce framework, which enables those tools to get the power of MapReduce and then be able to deliver it. The part of the problem we see with Hive is that it is just a SQL emulator. And in fact, we see quite a bit of performance issues with that over, more of an ANSI standard. So I think it's going to be a long time before that gap is closed between, Hive and the advanced visualization. So that's why really leveraging tools and technology like Teradata Aster to bridge that gap and then deliver the kinds of performance required for the business user to be able to do the iterative type of analysis. So it's not just let me run it once and get the visualization, but once I uncover that, how do I continue to drill through and evolve it?
Well, and I think that's a really good point, and some of the attendees have questions that speak to that, at least tangentially. And I'm thinking to myself, yes, I can definitely see what you're talking about, that it's easier now with some of these tools to do that data discovery, which I thought that was an interesting quote saying data discovery is the new data mining, but there's still just a whole lot of legwork, and that's the role of either the data scientist or the business analyst or somebody to either connect some dots or bring someone else in from operations, for example, to manually connect some dots and to employ some of the insights that you get from this stuff, right?
Yeah, absolutely. It's a great point.
Yeah, Richard, you want to comment on that too?
Yeah, I think another part of this gap between the visualization tools and the Hadoop infrastructure is this dark area called analytics or data mining techniques and things like that. The more we can, shall we say, characterize what happens in terms of the inputs to a complex analytics routine and what are the outputs, these tools can make smart decisions about when to apply them and when not to. Right now, you look at these techniques, and every one is uniquely different. They just don't fit into a pattern. And so I kind of challenge my academic colleagues to say, okay, can we, come up with some kind of template so that tools like Tableau, for instance, can you just choose from a library of 100 different analytics and be able to appropriately invoke them and bring the output of those tools into the visualization component that they have. Right now, that's all manual, and it's all, very, very complex. So that's another answer to that question.
Yeah, right. And let me throw out just a specific question here that one of the attendees has. And Chris, maybe you can kind of elaborate on this. What one of the attendees writes, how are social network users being tied to company accounts and specific customers?
So how are social network users being, what was the question again, Eric?
Yeah, being tied to company accounts. So they're talking about noticing what's happening on social networks and then being able to connect those social network users like Twitter handles and Facebook IDs and so forth to your marketing or your sales database or your customer database, that kind of thing. Is that something you've seen yet in any significance, or is that still pretty nascent?
Well, it is still pretty nascent, and obviously there's a lot of challenges between defining what's going on within an individual, both from a personal perspective as well as a company perspective, as they're making comments out there on the social networks. I think a lot of times, specifically around social network analytics, we're trying to really discover what are these key relationships between individuals, and how can those relationships really influence behavior, be either a purchase or a transaction. So we've seen things used quite a bit, like in retail. Is there some influence that someone has that maybe went out and they got their kitchen remodeled, and then who are 3 people within the influence of that sphere that also visits that individual that might also be a candidate for a kitchen remodel. And so really trying to understand the impact of one individual to each other, and then be able to influence their buying decisions and their buying behavior. So it's still an area that's evolving, but it is something that we think has a lot of golden nuggets that will provide more transparency as to consumers' behavior.
Right. And we have a number of different comments and questions and a great Twitter stream here today. So I'll just throw kind of a generic question over to you, Chris. What do you think are some of the biggest challenges in dealing with these two worlds and this sort of unified view, which I think is definitely the way to go, but what are some of the new big challenges for trying to manage this kind of environment?
I think the biggest challenge is making sure that you look at what it is you're trying to specifically do with what set of data, and make sure that you understand the value that we're going to be able to derive from that information, and then how we're going to monetize that. What I get concerned about is when people just say, well, it's big data and let me just capture it. Well, capturing it is just one dimension, and you can capture it, but if you don't leverage the tools to analyze it, and you've got to be able to analyze that information faster than an engineer can write Java code. If you don't use prepackaged analytics on top of the function around MapReduce and really be able to discover patterns at a very rapid pace, just capturing it is not going to provide much value at all. So I've even really emphasized it's not about big data, it's about big analytics, and how are you using analytics to discover. So I think the bigger thing is, yeah, let's capture the information, but make sure you have a plan to define how you're going to use and leverage that information through analytics.
Sure, and yeah, go ahead.
I would just add, the bottom line is, unless you take the big data and do something that changes the way you do business, that changes the products and services that you're offering, then all this is just a cost item. It's not delivering value. So you got to think all the way through to how it really makes an impact on your company.
Well, and I can say that we had Tasso Argyris from Astrodata on DM Radio a few weeks ago, another show that I do, and he had a really interesting concept that he threw out there, which was to use Hadoop on the front end of an information architecture, and wherever possible, have it serve as the entry point, because again, you can store so much more data now thanks to things like MapReduce, for example, that storage costs are not going to be what they used to be, but you still, of course, have this whole problem of trying to manage the environment and know when to start pulling stuff into your data warehouse. So I guess, Chris, I'll throw it over to you. How should an organization best alter the way they work with their data warehouse to start leveraging this whole new area of big data collection and analytics?
I think the main strategy is, keep doing, what you're doing with your warehouse. A lot of things that's really important to understand is these different architectures don't replace a warehouse infrastructure, because you still have to be able to have lots of concurrency, high availability, ability to run lots of users interactively within that kind of framework. But the key is create a discovery platform, right? And you can do things like you can download Teradata Aster Express, and you can test it on your own equipment, and you can bring in information and look for patterns. So the idea is discover some areas within your big data generation that you want to do analytics in, bring it into an infrastructure, create those nuggets, and then bring that into your data warehouse as a complementary data source to be able to then share and monetize with the rest of your enterprise.
Gotcha. Well, that's some good advice, folks. And we've gone a little bit long here, but we need to wrap up so that our panelists can get back to their everyday lives here. But thank you so much to Richard Hackathorn for entering the briefing room today. I think you had a pretty good time. Thank you very much, of course, to Chris Twogood and to Teradata. Folks, you can see the upcoming topics: intelligence, then disruptive technology, back to analytics in August. And we've got integration, database, cloud, and then innovators is in December. We do archive all of these webcasts for later viewing. You can find all that at insideanalysis.com. I'll just throw a comment out to one of the last questions here. I think definitely finance is an industry where you see a lot of leading edge stuff taking place. I think healthcare is going to increasingly be looked at as a leading industry, and some of the others, engineering and construction, are probably lagging behind a little bit. But big thank you to everybody and all those great questions, and a wonderful tweet stream out there, folks. We will publish this shortly, the archive, at insideanalysis.com. And I encourage you all to go to databaserevolution.com as well, where just today we finally published the comprehensive 40-page report on what's happening in the field of database. So check that out at databaserevolution.com. With that, we'll end our event. But once again, folks, thanks so much for all your time and attention. Take care. Bye-bye.